All right, to start chapter 5, we're going to start with a pretty simple concept, one I'm sure you've seen before. Talks about classifying triangles. And while this may seem like a pretty trivial thing, it is important enough for us to be discussing, so let's spend a little time with it. First off, I can classify triangles two different ways. I can classify a triangle by the side lengths, or I can classify triangles by angle measurements. When I classify by side lengths, I have basically three choices. I can have a scalene triangle, which all three sides are different lengths. An isosceles triangle, which has at least two congruent sides. And I have a special type of isosceles triangle called an equilateral triangle where all three sides are congruent. Please note that at least two sides congruent is for isosceles, which means that the equilateral triangle is also an isosceles triangle. So it's just a special type of an isosceles triangle where all three sides are congruent. And that's probably something you haven't seen before. Most people just say, well, no sides congruent, scalene, two sides congruent, isosceles, three sides congruent, equilateral. But there's that little technicality. We can also classify a triangle by its angles. When we classify a triangle by its angles, we always classify by the largest angle. Because there are always acute angles in every triangle. But the largest angle is what we look at to classify. We can have an acute triangle when all three angles are acute. We have a right triangle when the largest angle is a right angle. Notice the other two angles are still acute, but we do have a right angle. We have an obtuse triangle when the largest angle is obtuse. The other two are still acute, but we classify by the largest. And when all three angles are the same, we have a special one called equiangular triangle. Now, equiangular triangles are also acute triangles, but they're special acute triangles. So those are our four different ways of classifying it. So every triangle can have two names, at least. One for the sides, one for the angles. So I could have, say, a right isosceles triangle, or an acute scalene triangle, or an obtuse, well, I can't have obtuse and equilateral. That's not going to work. But I have obtuse isosceles or obtuse scalene. What I can't have is like a right equilateral triangle. That doesn't work. Equilateral and equiangular, we're going to learn in a little bit, but might as well just put it out there right now. These two always go together. So if a triangle is equilateral, it's also equiangular, and vice versa. I can't have a right equilateral triangle or an obtuse equilateral triangle. Equilateral and equiangular go together, they're special. What kind of a triangle does it appear that we have in this diagram? Let's go with our facts, not just with our eyes. Because I think if we go with our eyes, we might just look at this and say, oh, looks like an equilateral triangle. But the facts tell me this. I've got, again, my little tick mark here, my little tick mark here, indicating just the two sides congruent, so that is indeed an isosceles. An isosceles triangle. Draw an obtuse isosceles triangle and acute scalene triangle. So being able to draw something that's given to you in a verbal description, that's kind of an important skill. It's got to be obtuse and isosceles, so let's make my two sides congruent and form an obtuse angle. And then the third side comes in there. That's my obtuse isosceles. My acute scalene triangle, maybe something like that. Might have tailed off this end a little bit, but we have erasers for that. And I know a lot of you are going, well, you got a smartboard. What if I do it my homework and I leave a little tail on there? I'm probably not going to get too excited about it. But it is a good reason to work in pencil. So you can do a little erasing like that. This is the last example for the day, but it is probably the most complex. It says, okay, let's take a look at this, and let's classify what kind of triangle this is. Let's prove what kind of triangle it is. Is it a right triangle or not? Is it scalene? Is it equilateral? Is it isosceles? Clearly, we can see that it is not equilateral. I think that's pretty obvious. But we do have to determine if it's scalene or if it's if it's scalene or if it's isosceles. So how are we going to do that? Because we're in the coordinate plane, we do measurements. And how do we measure lengths in the coordinate plane? Distance formula. So I'm going to have to find the lengths of all three sides. Get used to this idea. You're like, I can hear the groans even right now from some of you who are listening to the podcast. Yes, there are going to be a lot of calculations involved sometimes when working the coordinate plane. Many distance formulas, many slope formulas, even midpoints sometimes. And that's why it's so important to know them and be comfortable with them, because we use them a lot. So let's start by finding PQ. And again, we're always going to label what it is we're finding. Start with our distance formula and fill in our blanks. The x-coordinates are -1 and 6. The y-coordinates are 2 and 3. And we simplify. -1 minus 6 is -7 squared. 2 minus 3 is -1 squared. So that's 49 plus 1, so square root of 50. That's PQ. Let's try QO. And again, same thing. And the x-coordinates are 0 and 6, and 0 and 3. So it's the square root of 36 plus 9, or the square root of 45. Not congruent. So I've got two different length sides. I'm pretty sure PO here is going to not be congruent as well, but we should prove it. So -1 minus 0 squared plus 2 minus 0 squared. That's the square root of 1 plus 4, or square root of 5. All right. So no sides congruent. That makes it scalene. We've proven that. 3 distance formulas. The next question is it a right triangle? Well, we can prove it's a right triangle by finding if any of the sides are perpendicular. Clearly, the only sides we have to check here for perpendicularity are PO and OQ. So I'm going to find the slope of PO. Slope, again, if I want to do slope, I could probably do this just by counting squares, but I can also do it with a formula. So let's use a formula for now. Slope of PO is change in y over change in x. So 2 minus 0 over -1 minus 0, or 2 over -1, which is -2. The slope of OQ, again, I can do change in y, 3 minus 0 over 0 minus 6, or 6 minus 0, excuse me. Got to be consistent with my order. Or 1/2. 1/2. Write what I say. There we go. Are these two lines perpendicular? Sure enough, PO is perpendicular to OQ, because the slopes are negative reciprocals. So therefore, yes, it is a right triangle. So this is a right scalene triangle. And again, -2 and +1/2 are negative reciprocals. That makes them perpendicular lines. The slopes are negative reciprocals and makes them perpendicular lines. Most of the work is just identification, but there is some stuff. So if you need to tonight, please go and review your distance formula, slope formula, that sort of thing. Know how to find those measurements, because it will be helpful tomorrow on your work. So we'll see you in class.